Now we'll officially define what it means for a function to have a limit at a particular point. Suppose we have the function, the mapping the set D, the domain, into the real number. Suppose that's a function, and x0 is just some real number that is an accumulation point of the domain. So not necessarily in capital D, but it's an accumulation point. The function f has a limit, L, at x naught if for every epsilon greater than 0, there exists a delta greater than 0, such that if x is in D, in the domain, and it is very close within delta of x naught, although not equal to x naught, then f of x minus L is less than epsilon. So the height of the function is very, very close within epsilon of capital L. So again, this implies that x being in the domain, not equal to it, not equal to x0. So once again, if x is very close to x naught, but not equal to x naught, then the height of the function f of x is very close to capital L. Well, let's do a real simple example. Taking this, we're going to find the limit as x approaches the number 4 of this function. So our x0 is equal to 4 in this case, and our function f of x is 3x minus 9. So first of all, the domain of this function is all real numbers. So is x not equal 4 an accumulation point of that set? Of course. If you took 4 plus or minus epsilon, 4 plus or minus a millionth, there are infinitely many numbers from our domain in that interval. So it's clearly an accumulation point. And secondly, this is a linear function. F of x is linear. In particular, it's continuous, so we can pretty much guess what the limit is going to be, right? You remember that from calculus? What are we going to use for capital L? Well, if x is going to 4, we're just going to take f of 4 as the limit, because it's a continuous function. Hopefully you remember that from calculus. And what is f of 4? It would be 3 times 4 minus 9, 12 minus 9. So L is 3. If you don't know the limit, or if you can't guess it, then you can't prove that the limit exists using the definition. Okay, so to prove or to show, maybe I should have used show because this isn't necessarily a formal proof, but I'll leave it. To prove that limit as x approaches 4 of 3x minus 9 is equal to 3, let's start off by just saying let epsilon greater than 0 be given.